In the last video, in section 12.2, you learned about series and summation notation. In this video, I'm just going to do a bunch of examples for you. First of all, the first two problems say write the series in summation notation. So in example 1, I have the series -4 plus 12 minus 36 plus 108, etc. The first thing that you got to do when you write it in summation notation is you got to put down the letter Z. And then what we need in parentheses here, or where the parentheses are, is the explicit formula that creates this series. So I have to find the pattern. What is the pattern between the numbers? Well, -4 to 12 to -36, upon close inspection, you're multiplying by -3. That means this is a geometric sequence. And if we recall, for the formula, the explicit formula for geometric sequences, which you learned in 12.1, what you do is you take the first term, which is -4, and you put the common ratio in the parentheses to the n-1 power. So there's my explicit formula for this problem. Now, underneath and above the summation symbol, I need to write what n goes from. And almost always, n will start at 1, because if I put 1 in here, if I put 1 in there for n, 1 minus 1 is 0, -3 to the 0 power. -3 to the 0 power is 1, times -4 is equal to -4, which is actually the first number in our series. So n equals 1, and then I believe you just count how many terms there are. First term, second term, third term, fourth term, fifth term, sixth term. So that means I need n equals 1 to 6 should be our formula. And we can test the last one as well, because if we put 6 in for n, I would have -3, oops, we got to rewrite that. I'd have -3 to the 6 minus 1 power times -4. And I believe if you do that on your calculator, you take -3 and raise it to the 5th power, you get an answer of -243 times -4, and you get 972. So that checks and works. Second example. Write in summation notation. 10 plus 7 plus 4 plus 1 minus 2. Well, if you look at the pattern there, it looks like these numbers are going down by 3 consistently. Therefore, this is an arithmetic sequence. Okay, so very simply, if I'm going to write this in summation notation, what I need is the arithmetic explicit formula for this pattern of numbers. And if you recall what that is, you have the slope, which is -3 times n, and then you need the 0 term. So I need the term that would be in front of 10. So if I go backward one spot, that would be 13. So -3n plus 13. And then again, n equals 1. So the first term, if I put 1 in for n, I get 1 times -3 plus 13, which does make 10. And then I count how many terms there are. 1, 2, 3, 4, 5. So n equals 1 to 5 of -3n plus 13 is our summation notation for this series. Example 3, let's go the other way. This one says expand and evaluate. Well, when you expand, all you do is you put all these numbers in for n from 3 up to 8. So very simply, if I put 3 in where the, oops, that should be an n, not a k, sorry. If I put 3 in for n, if I put a 3 right there, I get 3 halves. And it's a summation, so that means I got to add. Now I put 4 in for n. If I put 4 in for n, 4 divided by 2, we'll just leave it that way for right now since we're going to have the same denominator. Now what I do is I put 5 in for n, and I'll get 5 over 2. And this pattern keeps going all the way up to 8. So I have plus 6 over 2, plus 7 over 2, plus 8 over 2. And that's the expansion process. Now to evaluate. Well, all I do is add them all together. Well, they all have a common denominator of 2. Now I'll just add the tops. 3 plus 4 is 7, plus 5 is 12, plus 6 is 18, plus 7 is 25, plus 8 would be 33 halves would be the answer when I expand and evaluate this summation notation. All right, last, couple other formulas for you. Let's talk about a linear series. A linear series is any time you have just a letter right there in green. That would be linear, no power, just the letter K. So it says evaluate this series from n equals 1 up to 28. So basically what I'm evaluating is the numbers 1 plus 2 plus 3 plus 4 plus ... plus 27 plus 28. I want to add all the numbers together from 1 to 28. Now there is a formula for linear series. Anytime you have a linear series such as this, the sum or the final answer is equal to n times n plus 1, the whole thing divided by 2. Well, n is our highest value. That number right there is n. So in order to get the answer to this linear series, all I do is I stick 28 where the n's are. So I get 28 times 28 plus 1, the whole thing divided by 2. Now if you do that on your calculator, you go 28 times 29, and you get an answer of 812 divided by 2, and all the numbers added together from 1 to 28 make an answer of 406. And that's how you do linear series. Last one in this video, I'm going to talk about a quadratic series. Anytime you have, again, I should probably be using n's here, not k's. Anytime you have just a letter squared and nothing else, that's a quadratic series. Now, there's a formula for this as well. The formula for evaluating a quadratic series, and I'm going to write this in blue, and you should write these formulas, is n times n plus 1 times 2n plus 1, the whole thing divided by 6. The linear series, which I put in the blue box, and the quadratic series, which I put in the blue box, those things you need to write down. All right, so let's finish this problem. It says evaluate all the squared numbers from 1 to 12. So basically that means if I stick 1 in there, 1 squared is 1, plus 2 squared is 4, plus 3 squared is 9, plus 4 squared, which is 16, plus ... all the way up to 12 squared. Our highest number is 12. 12 squared is 144. I want to add all those numbers together. Well, to do that, I use the formula in the blue box. And n is the highest number at the top of the summation symbol, which is 12. So I put 12 in for n, and then 12 plus 1 in for n, and then 2 times 12 plus 1, the whole thing divided by 6. So if you type this in your calculator, what you're going to type in is you're going to type in 12 times 13 times 25, which is 2 times 12 plus 1, the whole thing divided by 6, and you come up with an answer of 650. That is what all these numbers squared added together equal. And that is how you do your assignment. I believe that covers most of the problems on your assignment for section 12-2. If you have further questions, please let's go over them in class.